Welcome back to Outward Home Learning. This is computer science and today we're looking at abstraction. So to tell us a little bit about abstraction, we're going to go over to Mr. Holton, and then you've got an activity to do based on Alcatraz prison, and then you've got some exam questions to complete. So we'll go over to Mr. Holton to explain a bit more.
Every computer game that you've decided to play, every simulation that you might have seen, pretty much every computer program features some form of abstraction. And without it, no computer program would ever get made. Why is it so important then? Well, let's just cover a definition. What is abstraction? It's removing unnecessary detail from a problem that we're trying to solve with a computer program. And what I'm going to do first is take you away from computer science a bit and just show you how this works in drawing, because the idea holds up. So I'm going to give myself about 10 seconds to draw a cat. So here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, 0. Okay, there's my cat. All right, now as you see, I'm not the world's most, I'm going to add a mouth there. I'm not the world's best drawer. You can see that. But if I showed that picture to somebody and I asked them what it is, they'll probably say it's a cat, even though it looks nothing like an actual cat. I mean, compare the two. There is this very real difference between these two pictures. But the reason why we'd probably recognize this as a cat still is because it's got some key features. So it's got the pointy ears, for example. It's got whiskers. It's got 4 legs, it's got a tail, got eyes, got a nose. So if my problem is to draw a picture of a cat, then I'm going to do the one on the left hand side because I can draw that one much faster. I've removed a lot of unnecessary detail and it's simpler to do. There's just simply less to draw. So let's give you sort of a real example of this, how this has worked. Maybe in creating a computer game. It's very easy to sort of pick out abstraction in simulations and in computer games because we think about, okay, what is the difference between what I'm seeing now and the real world. So the game you're seeing on the right is called Roller Coaster Tycoon. It's an old game. I've deliberately picked an old one because I know it will have a lot of abstraction in it. And the idea of this game is building your own theme park. So if I'm using abstraction, I've got to ask, okay, what are the important things? What do I keep in? But what am I going to abstract out? What has been abstracted? What have I removed from real life, which I don't have in this game that you see on the right? And you can see, if you think about it, a heck of a lot actually. You might see we've got like things like roller coasters and stuff like that, but we haven't got things, I don't know, let's just start off with things like insects. There's no insects in that game that you can see. Okay, we've got crowds of people and things like that in it, but we haven't got any sort of simulation of any sort of weather that I can see. I can't see any clouds or any sort of rain. So these are decisions, deliberate design decisions that somebody has made to remove from the game. Why do we do it then? There's a few different reasons for this. Well, if you imagine that you had to make a game about a theme park, but you had to make it as close to real life as possible, it would take a lot longer. So it's the length of time it takes to develop a solution. That's why we use abstraction. It reduces the length of time taken to develop a particular solution. This is because we're naturally making our problem less complex, and that is a huge one. So it's easier to solve because the problem is less complex. I've got less to have to worry about. And also, if we think about it, that makes it more likely for a project or a game to succeed. Simply because now I'm looking at a development time of maybe a couple of years as opposed to a couple of decades. I mean, a lot can go wrong in that time, but this is a big one as well. If I decided to try and model everything in the real world, down to all the air molecules moving about that theme park, I would struggle to find a computer to actually run it. So when we use abstraction, we also use it to make the program we are creating require less resources on the computer. And that is things like, yes, CPU and memory in the main. So they're the solid reasons for using abstraction, is we always have to use it at some point for computer programs. It's just this idea of removing unnecessary detail. Hope you enjoyed my cat picture.
So for your first task, you're now going to abstract a map of Alcatraz prison. So this is a little bit of a different one. You need to double click the image and you'll be able to start editing it as a Google drawing. But if you open up the abstraction activity, follow the instructions on there and you've got about 10 minutes to complete that. So 10 minutes is starting now. Okay, so that is time up. Over to Mr. Barnes to explain the answers.
Okay, so let's have a look at this activity around abstraction. So what we've got here is we've got an aerial photograph of Alcatraz prison in San Francisco. It's known as the Rock. Now, your job is to take this photograph and create a map of the prison using abstraction. So remember, abstraction is about ignoring the unnecessary details and focusing on what's important. Okay, so with a map, the things that are important are they basically allow you to signpost whereabouts you are, maybe in this case on the island. So if I move this up slightly, I'm going to have to move up a little bit more, probably off screen. We've then got a drawing here. Now you can double click on it and edit electronically. I'm going to do it manually. So there's not necessarily one right answer here, but I would say that on this map, some of the most important things that need to go on are these buildings. Okay, so I'm going to start with the industry building, which is in this top corner. Okay, and I'm just going to write industry building. Okay, then slightly further down. Okay, and obviously this is really useful for anyone wanting to escape from Alcatraz. If you haven't watched the film The Rock, I highly recommend it. So we've got power plant. Okay. And then further down here we've got some apartments. So excuse my horrendous drawing, but this looks something like that. Let's move that back up. Okay, so we've got our apartments. We've also got the docks. So I'm just going to write docks because they sort of stick out and show themselves. We've then got the lighthouse. Okay, I'm just going to put lighthouse. And off the lighthouse, what we've got the main cell block, haven't we? So we've got the main cell block. Now this could be interesting. Now I draw this. Obviously it's not going to be perfect, but it will do. So main cell house. And it's starting to take the form of a bit of a map. Okay, what else have we got? Let's have a look. So we've got the rec yard, the recreation yard. So that's going to be like out of here somewhere, something like this. Okay, and we've got the laundry building. And this is where my scaling's not great, but we will survive. So we've got laundry. And last but not least, we've got the water tower. Now, this starts to form a much simpler version of the map that someone could follow. But it's not just the buildings that need to be involved, because there's other things that allow you to identify where you are in relation to the island. So, excuse my really bad drawings here, but it's probably good to put on, you know, we've got trees. And also, bearing in mind if people want to walk around it, like the paths. Okay, so they can see how they can get from one area to another. And obviously you can take a little bit more time than me doing this to give yourself a better job. Okay, and you've got a path that goes up here. Oh, really, really bad drawing, it has to be said. Okay, so you can start to see how you would move and navigate around this island. Okay, and what I've done there is, does it matter if it's uphill or downhill? Well, no, it doesn't. Does it matter what colour the trees are? No, it doesn't. Does it matter what colour the buildings are? No. Does it matter that some of the buildings are in disrepair now? No. Okay, but you can see the layout, and that is abstraction. It's removing the stuff that we don't need to worry about to create a map, to be able to navigate around the island, and only focus on things that are, which are, in this case, where things are, how to get between them, and so on. So there are lots of different ways, and you could be very, very creative with this and do a much better drawing than mine, but there's a rough overview of how abstraction can be applied to an image and a problem.
So it's now time for you to answer some exam questions to prove your knowledge. These will be reviewed afterwards, but you've got 10 minutes to complete them. There's 3 questions. Best of luck. And now we'll go over to Mr. Barnes to review those answers. Please make sure you amend them if you need to.
Right, let's have a look at these exam questions as part of our deliberate practice all around abstraction. So we've got question 1 then. A school kitchen stores details of each student in the school, so students are able to pay for their meals. The kitchen computer system stores an abstract representation of each student. Describe what is meant by abstraction. So the key thing here is it's 2 marks. It wants to know what abstraction is, and actually the scenario in this question is almost irrelevant. So what is abstraction? So abstraction is when unnecessary detail is removed from a problem so that you can focus on the important aspects to make it easier to solve the problem. Okay, so I think I've got 2 marks there, one for the unnecessary detail bit and the one about focus on the important parts. So next up then we've got explain why abstraction is used by the school kitchen when storing details for each student. Okay, so the kitchen, and this is quite a tricky example, so now it's wanting it in context because it says why in the school kitchen. So the kitchen will only need certain information. Abstraction will reduce the complexity and make it easier and quicker for them. Okay, that's a real hard question, that. So we'll look at the mark scheme for that in a second. And then finally we've got teachers and school kitchen staff use different abstract representations of a student. Explain one way in which these abstract representations differ, that should say. Rather than offer, it should say differ. Okay. So, well, a teacher will want to know data like marks and attendance, but a kitchen wouldn't need this. They would want to know things like allergies. Okay, this is a very, very hard question overall, I think. So let's go through it in a bit of detail. So we've got here then, describe what is meant by abstraction. So we've got obscuring of unnecessary detail. Okay, so this is when unnecessary detail is removed from a problem. Okay, and that is more than saying do not allow simply removing detail, because it's about unnecessary detail. Okay, so the main process or data can be easily understood or focused on, so you can focus on the important aspects to make it easier to solve. 2 marks. Very difficult question. Question part 2 then of A is explain why abstraction is used by the school kitchen when storing details for the student. Well, I've put the kitchen will only need certain information. Abstraction will reduce the complexity, so we've got reduce the complexity, and make it easier / quicker for them. So therefore make implementation more efficient, simpler, quicker. Perfect. Okay, and then finally, we've got the teacher and the kitchen and how may they use it differently. So I've said a teacher will want to know data like marks and attendance. So we've got here teacher would hold details, marks, grades. But the kitchen wouldn't need this. Well, the kitchen system would not need academic information. I've said they would want to know things like allergies, and you'll see it down here, but it says marking pairs, so it's one way or the other. So I could have just said kitchen needs things like allergies, teacher doesn't need this information. And there's our 2 marks. That is a real difficult sort of set of questions there, and this last question is e.g., so any suitable comparison about what's needed and what's not is more than acceptable.
And that is what you need to know about abstraction for GCSE Computer Science. Well done for taking part, and we will see you next time.